Have you ever written code that works but runs too slow? Or maybe it takes up too much memory? Today we will break down two key concepts: time complexity and space complexity, helping you write efficient programs. In this video, we will cover what is time complexity, what is space complexity. We'll also demonstrate code examples for each of the topics, and also see optimization strategies. Welcome to this tutorial. If you are new here, don't forget to subscribe for more Python programming insights. Our goal is to help you write better, more efficient code so you can tackle any coding challenge with confidence. Now, let's get started. What is time complexity? How fast is your code? Time complexity tells us how an algorithm's running time increases as input size grows. Let's explore this with a real-world example, searching for a user in a database. In this example, searches for a user in a list by checking each element one by one. This is a linear search algorithm. In a linear search, we check each user one by one. If there are n number of users, the worst case scenario is checking all n elements, making it big of n complexity. This linear search algorithm approach is slow for large datasets. Let's see another example using binary search. Uses binary search to efficiently find a user in a sorted list. Binary search works by continuously dividing the list in half. Instead of checking n elements one by one, it eliminates half the search space in each step, resulting in big of log n complexity. So, binary search is more efficient than linear search because it uses a divide and conquer approach, halving the search space with each step, which reduces time complexity. Next, let's talk about the space complexity. How much memory does your code use? The space complexity measures how much extra memory an algorithm needs. Let's compare two ways to handle social media posts. The first one is storing data in memory. This creates a list storing all posts in memory, consuming extra space. Here, we store every post in a list using extra memory proportional to n number of posts. This results big of n space complexity. The next example is streaming data without extra memory. This streams posts directly without storing them using constant space. Instead of storing all posts, we process and print them on the fly, using only a few variables. This keeps space usage constant, big of 1, complexity, no matter how large n is. So, this approach is highly recommended compared to storing all posts and checking them one by one. Now, let's move on to discussing optimization strategies. How to optimize your code? Choose big of log n or big of 1 algorithms when possible. Reduce extra data structures to optimize memory and use efficient searching and sorting algorithm techniques. So this is today's tutorial. I hope you enjoyed in this video and you know the difference between time complexity and space complexity. Next time you write code, think about how fast it runs and how much memory it uses. See you next time. Thanks for watching today.